As the ski season draws to a close, I just kind of want to reflect on how things went this year. There's been a lot of ups and downs, and what the future looks like. I was thinking that this season was over. That was like a month ago in early March. And then things really turned around, and we had a lot of snow in the latter part of this season. Today is April 9th, 2024. It's the day after the total solar eclipse. I'll just show off my picture right here. Not only did we have a solar eclipse, we have a beautiful clear sky day like today, which is pretty unusual in April in Vermont. And we also have a ton of snow. That's also pretty unusual in April. So lots of good stuff coming together. But this season wasn't all good. There were a lot of ups and downs. And it was just a big struggle to find enough cold air to get the precipitation that did fall to turn to snow instead of rain. And in a lot of cases, it just fell as rain, primarily in the lower elevations, and then the higher elevations, like up here, I'm standing on the summit of Mount Mansfield, it fell as snow. So we have pretty significant snow depth at the upper elevations, and then almost nothing at the lower elevation. So I actually think that this season holds a lot of clues as to what the future may hold, and I'll talk about that in a minute. But it wasn't all bad. Let me show you a few great days. I was up here regularly with some students and working on this snow monitoring project, and we had some amazing days up here, amazing experiences working on our snow project. So I think if you could summarize the snow this year in the 2023-2024 ski season, I think you could say that a lot of the snow that did fall was with the larger storms, and when we had smaller events, it tended to fall as rain. And in fact, there is a study that is primarily done with computer models that kind of points to this sort of thing, where the smaller events tend to not fall as snow, and then the larger, bigger events, I'm talking nor'easters, it tends to be bombs away with snow. And in fact, that's what happened in early April in our big nor'easter that came through here. It was actually a big surprise to a lot of us how much snow actually fell in early April. I think a lot of this has to do with abnormally warm sea surface temperatures. The sea surface temperature in the Gulf of Maine is one of the fastest warming parts of the ocean in the entire world. So when you have these cold air systems, so Arctic cold air coming down from Canada that interacts with the very warm air on the sea surface, that is a recipe for really strong storms. And in case you're not familiar with New England weather, a nor'easter is a strong offshore low pressure system that constitutes some of the biggest snow events that we have here. So there's a low pressure, and we have the rotation of the air. The nor'easter refers to the northeast direction that the winds are coming from, and it picks up all sorts of moisture from the sea surface. And because the sea surface is warmer, the Gulf of Maine is one of the fastest warming areas in the entire ocean. There's a lot of moisture to wrap around and hit New England, including Vermont. But it affects pretty much all of New England when these storms hit. So with all of that added moisture, because it's getting warmer, the air is getting warmer, and the sea surface is getting warmer, there's a lot more moisture and then a massive snowfall. That is exactly what we saw in the early April storm. But it's those lesser events where it's cold air fighting with warm air, and when it's like this past year was an El Nino year, and that favors warm air, so the warm air has been tending to kind of win out. And with a steady warming of the climate and more warm air, probably also related to sea surface temperature warming, I think we're going to see likely fewer smaller snowfall events. So we've taken a look at some of the long-term records of snowpack in this area, and there are a few things to note that come from this. So over the course of the last 57 years, and it's 57 because that's when we have reliable records that are able to be analyzed, we noticed that the average length of the ski season is about 3 weeks less than it used to be back at the start of that period. So that kind of just goes to show that there's been this period of rapid warming. And in fact, New England, especially in the winter, is one of the fastest warming areas in all of North America. So I've made a video about that already, so I can point you to that. And it kind of describes why this is and what the magnitude of that is as well. So in addition to that, the total snow water equivalent, this is all of the water that's locked up in the snowpack, has decreased by 13% over that same period. So that's a pretty substantial decrease in the water that's locked up in the snowpack. But when talking about climate change in the Northeast, it's important to remember that it's not only about averages, it's also about the fluctuations, or in other words, the variability. So, for example, what we've been noticing a lot of is, on a daily scale, lots of ups and downs in terms of how warm it gets, how humid it is, and rain that falls for maybe one day or so, and then not the next day, or maybe a couple days. But the point being, if you take a monthly average, that would wash that out, and you wouldn't see any of that signal. But if you think about the events that we call like a January thaw, they would have an outsized impact on what happens with a snowpack. They just eat away at the snow. And so it's important to remember that climate change is also changes in variability in addition to changes in average conditions, like the gradual warming. Part of this project also entails measuring snow depth from a drone using a LiDAR. So you get a nice spatial extent of what the snow depth is. And we do that with snow on the ground and then without snow, so that you can compare the two and get a map of what the snow depth is. And so we compare this to model output and try to understand how things like slopes and topography and wind patterns and tree cover and all of these types of things affect how much snow is in a particular place and how fast it melts. So now let me take you down and show you a couple of our sites where we're measuring snow depth. So normally it would be quite a stretch for me to reach our little instrument right here. This is a ultrasonic snow depth sensor. It sends a little signal down, it bounces off top layer of snow and back up, and then it measures the time elapsed for that signal to go down and back, and that gets converted into a distance. So that if it's referenced to the ground level, then that gives you a snow depth. So here's a solar panel, and buried underneath there would be some instruments, an enclosure that has a data log. So to conclude, what actually happens in the future is really anyone's guess, of course. I obviously don't have a crystal ball. Nobody knows what the future holds. But if I were to guess, I would say that the future probably looks a whole lot like this year did. So to summarize, that means bigger storms due to the intensification of nor'easters. So that's related to the continued record warmth in the Gulf of Maine as well as other parts of the North Atlantic. We are going to see less precipitation falling in the form of snow in the interstorm periods, because there is going to be a continued struggle to get enough cold air to get precipitation to fall actually as snow versus rain. So there'll probably be plenty of precipitation to go around. It's just likely going to fall as rain instead of as snow. So that's my second prediction. So the third prediction is that the variability on a day-to-day basis is probably going to keep increasing. So we're going to see increasing midwinter thaws, what we call January thaws around here. So that's my third prediction. And those are going to have an outsized impact on snow that isn't, I don't think, fully appreciated yet. So that's probably going to be more and more of an issue in coming years.